In this video, we'll be going through some of the common ways we view and assess the road strings, cross sections, and tin that we just created. The first thing we want to take a look at is the cross sections. So I'll bring up the LS section view and fit that to the bottom right. Then I'll bring up the XS section view and fit that to the top right. I'll then select the profile icon on the XS section view toolbar. Then pick and accept one of the cross sections toward the start of our road, say at change 60. So left click and accept. And you can see the cross section being profiled in the view. Now there's no real difference between these LS and XS section views other than their name, but I'll set this one up with a grid that suits the cross sections specifically. So I'll select the properties icon. Select grids from the left and select draw grids first on view. The grid X I'll make 5 and the grid Y I'll make 0.5. So that's created a grid suitable for the cross sections. And then finish. Now, like we did for the long section, we'll add the ground tin to the view so we can see how this cross section interfaces with it. So I'll pick the add icon and add tin ground. I'll also toggle on the grades of each of the segments of the cross section by using the toggle icon in the section view and selecting grades. And now we get reported at the top of the view the grade and width of each of the segments of the cross section. We'll also add the road strings to the section view. So I'll again select the add and select design RS1. And then you can see each of the longitudinal road strings and where they pass through the cross sections. Now you can see on the left side of the road that the last link of the fixed part of the template, which is here, so the FBL link, as you can see there, is below the existing surface. So that's why the cross section cuts up to meet the ground tin. And that has a 2 in 3 grade, or 66.667%, because that is the grade of the first link in the variable cut part of the template. So if you recall, back in design, templates, create edit, if we pick full left and then cut, you can see here that the slope is reported as 1 in 1.5, which is 66.667%. Conversely, on the right side of the road, because the FBR link, which is this one here, is above the existing surface, the cross section fills down to meet the ground tin. And this has a grade of 1 in 2, or 50%, which you can see at the top of the view, because that's the grade we specified in the final cut fill part of the template. We can also tell in the plan view when these interface links are being generated in cut or fill by looking at the color of the interface link at the edge of the cross section. We can see on the south side of the road, which is the left side, the interface link is initially green, but then it turns to red. And similarly, on the north side of the road, which is the right side, the green interface link just extends a little further, but then it turns red as well. What these green and red colors indicate is whether the final link before the interface link is in fill or cut. So green indicates fill and red indicates cut. And something I have mentioned but didn't show in a previous video is what these left and right arrows do in the section view toolbar. These arrows allow you to cycle through the strings on the model which is being profiled. And in this case, when we have all of the road cross sections in the same model, these left and right arrows will scroll through the previous and next cross sections along the road. So if you click right, you'll move in the positive change direction, so you can see how the cross sections change as you move down the road. Now sometimes you'll want to look beyond the extents of the cross section to see whether the ground tin continues in the same manner or changes. So to just extend out the view, we can select the Properties icon in the Section View toolbar, and then select the Profile Extend node from the left. Then we can say extend the view by 10 meters on the left and 10 meters on the right. And now we can see 10 meters further of what the ground tin is doing on the left and on the right of the road. So I'll finish that properties panel. So they're the main tools with cross sections. And it's not only the cross sections we can profile, we can also profile the longitudinal road strings. I'll profile the road strings in the LS section view because that has an appropriate grid setup. So I'll select the Profile button, then zoom in and left click and accept on the FBL string, which is this one here, and accept. And we can see how this particular string runs relative to the ground tin along its alignment. We can even profile the interface link on the left side of the road. And as we'd expect, because this link's purpose is to provide an interface to the ground tin, this link matches the ground tin exactly. And we can even determine with the red or green color of this string where the link immediately before the interface link is below or above the ground tin. So that's the section view. And now we'll move into some tools we can use viewing the design in the perspective view. So I'll open the perspective view again. And one really nice feature is the View Drive feature, which enables us to drive along the center line of the road and see what it would look like for someone driving a vehicle. So to access this feature, we click the wheel icon on the perspective view toolbar. And we just have to fill out the parameters for the drive. So the eye location, the target location, and the speed. I'll change the eye height to 5 meters so we get a little bit more of a raised perspective. I'll pick the string to drive along, which will be the super alignment. And 100 kilometers an hour should be fast enough. So then select drive. And then we get a nice drive down the road, showing us all the cut battering and benching as we go along where we're in deep cut, and just generally gives us a good idea of what the road will be like to drive on. At any time, we can right click to stop the drive, then press drive again to continue. So obviously this is just the design surface that we can see in the perspective view, but ideally we'd like to be able to see the existing surface or the ground tin as well. But if we add the existing surface to the view, then it overlaps the design surface, and where the ground tin is higher than the design, we can't see the design. So to combine both of these surfaces together, we'll create what's called a super tin. A super tin is a composite of multiple tins, and in this case we're going to take the ground tin as a base, then where the road tin exists, this super tin will take the ground tin and replace it with the road tin. To make this super tin, we'll select Tins, Create, Super Tin. We'll name this super tin Super, then press Enter to fill out the model for tin field. And in the bottom table, I'll right click in the tin column and select the ground tin first. Then insert another row below. Then do the same and pick the RS1 tin in the next row. And select Create. That will have created the super tin. So now I'll go and remove the two tins from the perspective view and add the tin super. So now when we zoom in, we have a composite of the two tins, with the ground tin being removed where the road tin exists. And a nice look at what the road and surrounding area will look like. Again, we can run the same drive, just making the chainage 0 to start, then drive.